Okay, AP Stats fans, our topic for today is 9-2, tests about a population proportion. Before we begin, let me give you your joke of the day. How did Darth Vader know what Luke got him for his birthday? And the answer is he felt his presence. All right, we're going to start with a review, but we're actually going to be looking at a couple of different pieces of information. So here's a problem. This is a chapter 8 problem because it's about a confidence interval. So we're going to review how we can calculate a confidence interval and what that tells us. Mr. Cavell wants to find out his free throw percentage, so he takes 50 free throws and makes 32. All right, that's me. I'm shooting. Hopefully I'm making it. Part A, construct and interpret a 95% confidence interval for the proportion of all free throws Mr. Cavell makes. Part B, based on Part A, can we conclude that Mr. Cavell is an 80% free throw shooter? Now, before we do this, we have talked about a couple of acronyms that help us to remember some of the processes that we go through. The first one we did, this was chapter 1, was SOX. This was to describe the distribution of one variable, of a quantitative variable. So we talk about the shape of the distribution, whether it's skewed, whether it's symmetric. We talk about outliers. We talk about the center, the median and mode. We talk about the spread, which could be standard deviation or the range or interquartile range. In chapter 3, when we were looking at scatter plots and two quantitative variables and trying to describe that relationship, we talked about SOFA, we talked about the strength of the relationship, we talked about if there were outliers. The form would be talking about whether it's linear, whether it's curved, and then the association is whether it's positive or negative. Now, in chapter 8, your book goes through a process. They say you state, you plan, you do, and you conclude. But if you're looking for something a little bit easier to remember, then our acronym is going to be PANIC, which doesn't really sound like a good thing, but PANIC might be a little bit easier to remember. PANIC means we start by stating the parameters. It's going to be the same thing, but again, this might be a little bit easier. So P is for parameters. A is the assumptions that we're going to make. Now the assumptions, those are the conditions that we need to test for. Random, 10%, and for a proportion, it would be the large counts. N is where we name the interval. Now both of these, if we were doing the state, the plan, the do, and the conclude, this would be the plan part. Do is where we actually do our calculations and we find the interval. And then the last part is we make our conclusion. Okay, so PANIC. State the parameters, assumptions, name the interval, find the interval, and make the conclusion about it. Okay, so in this case, we're talking about proportions. So the P, we're going to state the parameters. We're going to say P is the true proportion of free throws that Mr. Cavell makes. Okay, so P is the true proportion. Now, the A and the N, we have to check our conditions, and we have to name what kind of interval we're going to be doing here. This is a one sample interval, Z interval, sorry, a one sample Z interval, because with proportions, we're going to have to use the Z statistic for that. Now, we can't do that unless we are certain that we've met the conditions. Now the conditions would be, is it random? Let's assume that the free throws that I'm shooting, that if I was doing a bunch of samples of this, you just took one of my random samples for that. So let us assume that it's random. 10%. Let's assume that I'm taking more than 50 or 500. 50 is less than or equal to the number of free throws, the 10% of the free throws. So let's assume it's independent here. And then the large counts condition, now that would be n times p for the large counts. So that would be 50. Now the proportion in this case, n times p hat in this situation, it would be 32 out of 50, which is 64%, 0.64. Now that would just equal 32. N times 1 minus p hat is 50 times, that would be 18 over 50, which is 18. Both of these are greater than or equal to 10. So large counts is good for both of those. So all of our conditions are met, so we're going to do a one sample z interval. So this was the p. This was the assumption here. Okay, the n, so this is where I would name, we're doing a one sample z interval. Okay, this is what I put before. If I'm doing the state plan, it was part of the plan right there. So parameter, here's our assumptions. Okay, let's assume these are good. Large counts mean we can assume that it's going to be a normal approximation. N, name the test, or the interval is a one sample z interval. Okay, now let's figure out what the interval is. Now on the formula sheet, which I'm going to show you, what they give us is for a confidence interval, we take the statistic plus or minus the critical value times the standard deviation of the statistic. In this case, our statistic is p hat plus or minus. The critical value, because it's a proportion, it is z star. It's going to be a z critical value. And times the standard deviation. Now the standard deviation for the proportion, since we don't know what the true proportion is, we're going to have to use p hat times 1 minus p hat divided by n, which is 50. That's the number of free throws that we're taking. Now it's a one sample z interval, and also let's write down, this is a 95% confidence that we need. Now a 95% confidence is, we already know that, you may have already memorized that the critical value is 1.96, but if not, you can use the calculator to get that, and I actually left my calculator in my bag, so I'm going to run real quick. Now I've got it. I'm coming back to my seat. And here we go. That just took a few seconds. Sorry about that. And we go. I would do an inverse norm. Now in my calculator for a 95% confidence level, I need to type 0.975. It should be 1.96, and it is. So there's our critical value there. We already know that p hat is 32 over 50, which is 0.64. And so now we can do 0.64 plus or minus the critical value, which is 1.96 times the square root. It would be 0.64. Now 1 minus that is 0.36 divided by 50. And I can use the calculator now. I'll do 0.64 minus 1.96 times the square root. 0.64 times 0.36 over 50 divided by 50 equals, so that would be 0.507. So 0.507, comma, and then I have to add it. And that would be 0.773. So 0.773. So this would be our confidence interval right there. I don't have to go through all this because on the calculator, I can do a test, stat tests. I would go to a 1 proportion z interval for that, where it's 32 over 50. I'll make the confidence level 95. Calculate, and there it is, 0.507, 0.773. The sample proportion is 0.64, and then n is 50. That was the number of free throws that we're taking. Okay, so we calculated that. Remember that this part here is called the margin of error. The square root part, this is the standard deviation, but because this is not the true proportion, this is what we call the standard error for that. Here's the interval. So we've got the parameter is the true proportion of made free throws. Here's the assumptions. We test our conditions. The name of the sample, name of the interval, 1 sample z interval, 95% confidence. We do the interval, and then the last thing here is we conclude. We make our conclusion. So we are 95% confident that the interval from 0.507 to 0.773 captures the true proportion of free throws that Mr. Cavell makes. Okay, we are 95% confident that this interval, that the true proportion is somewhere from here to here. So it could be at 0.76, it could be at 0.51, but we're 95% confident that the interval is somewhere here. Now that's part A, so that's the whole interval that we just went through that process. Part B says, based on part A, can we conclude that Mr. Cavell is an 80% free throw shooter? All right, now, here's the problem. 80% is not in this interval. 80% is outside of this interval. These are what we call the plausible values. Plausible means it's likely. It's something that would make sense. If 0.8 is not in the plausible values, now it's possible the true proportion could be 0.8. I could make 80% of my free throws, but it is highly unlikely. So for part B, can we conclude that he's an 80% free throw shooter? No, because 0.8 is outside the confidence interval. And what that means is that it is not plausible. Okay, now we're going through this and you're saying, well, this is not a significance test. This is all from last chapter. And that is correct, but it's this last part here where we need to make this connection. Because when we do the significance test, now we're going to basically come up with the same answer, but we're going to come up with it from a different way. So this is not plausible. If it's not within your interval, assuming that everything we've done here is correct, then anything that's outside of that doesn't really make sense for the problem. And that is the end of part 1.